Is it? Are you actually?
Yeah, we're still on.
We have this mic off and the.
Okay. Good. Okay, I'm Jim Kelly. As you said, I've been the security architect for NT since way back when. What I'm planning on doing is like you said, is take a fairly high look at security. There's some people that are probably fairly familiar with security, and some of this will bore you. But a lot of you, this might be your first introduction to security, and so it's not so boring. And then Robert will talk about what it takes, including code examples and everything, to actually incorporate security into your file system. There's two ways to look at security, and we're going to kind of cover both of them. One is what are the topics that users see, what are the components of security logically from an architectural point of view, and the other is what are the components, pieces of software that exist in the system. If you look at the components as pieces of software, this is a list of them up on the screen. There's something called a local security authority. It implements what we call the security policy. That includes things like who are privileged users on this system, what kind of auditing do we do on the system. It handles also who can log on to the system, which goes along with who are the privileged users. When you're logging on, we tack on privileges, things like that. Then there's something called the reference monitor. That's a name taken from the National Computer Security Center, straight out of the Orange Book, what that piece of software does is all the access validation. When you get a user asking to access a file or a process or an event or something like that, all the calls to evaluate that access come into the reference monitor, and there's one piece of code that makes that decision. There's logon processes. These are pieces of software that pretty much are responsible for talking to some device that a user might log on to. We have several in the system. The most obvious one is keyboard, mouse, screen. That's the set of devices that you can log on to. Looking at it at a little higher level, you can log on via the network. Somebody can come in through the network. We actually have to log them on at that point. There's something called the service controller you're probably familiar with, kind of not a batch queue, but background activation mechanism. You can log someone on via that mechanism. So there's several notions of logon processes in our system. This is a picture of what these components look like in our system. And you can see the reference monitor lives down in the executive. We actually have callers of the reference monitor that live in user mode and callers that live in the executive itself. File systems are one example of where you'll be calling the reference monitor from the kernel. But there's other things, user mode subsystems that exist up in user mode. And we have system services available to do access validation there as well. Win32 API. Let me go over real quick here. I'm trying to figure out, oh yeah. These things here, does that show up everywhere? Those are the logon processes. One of them you're very familiar with, WinLogon. That's the thing that when you walk up, hit Control-Alt-Delete, it puts up the hi, welcome to the system. Please enter your username and password and domain. In the PowerPC release, good chunks of that will be replaceable. I would imagine a lot of you that are interested in a conference of this level might, in fact, I've talked to a couple of you already, are interested in changing other aspects of the system. WinLogon is one place where you'll be able to change what the system looks like. If you want to use a smart card for logging on, or you just want to change what the thing looks like, it's still going to collect the same username, password, and all that, but you want it to come up and say, you know, XYZ Corporation warning if you're not authorized and all this, and you can do that. WinLogon is the piece of code that implements all that user interface. It also implements a lot of other things that go along with it. So we've isolated all the user interface in one piece of code. It's a DLL called GINA, Graphical I&A for identification and authentication. So you can just write a replacement for GINA, plug it right in. Service controller I talked about, the network, these are all people that call. The interface to the security authority from those guys is really simple. So if you have a need to add a new batch queue or do a remote command shell or something like that, you end up writing one of these logon processes. If you end up writing a logon process and you're, say, a network, say you're going to do a new network protocol and you have your own authentication database out on your network, you might not want to use our account database. You might want to go off to your network and access your account database, or you might want to do both of them. If you want to do that, there's these things down here called authentication packages. There's a standard interface, so each one of those is a DLL as well. There's a list of them in the registry that we load up. You can add to that list. Right now, we load up by default just the one called MSB10. You can add as many as you need to. And the rest of it, reference monitor down there. Now, what I'm going to go into for a while here is pretty much data structures that correspond to concepts. And maybe I will, if the mouse click changes the screen. Do I have to go back down there? There we go. There's several data structures, pretty much each one representing a concept that you need to be familiar with before you can understand the details that Robert's going to talk about. These are the major data structures here. There's something called a security ID. When you log on to a user account. That account belongs to some number of groups. Inside our system, each one of those accounts is represented by a security ID. Now, in general, you don't need to care about what the structure of that thing is. It's a variable length structure, and you have to treat it as such. Don't allocate, 48 bytes or something and say, well, the security ID is going to fit in there. But you don't really have to pay too much attention to what the structure is. I've included it a little later, but I'm not really going to go into detail and talk about it. I just put it in here for reference. There's something called an access mask. And access masks are used for two different things. When you go to protect an object, a file, process, whatever, you usually stick on who's going to get access and then what access you want them to have. Well, the who is the security ID that we already talked about. What they're going to be given access for is the access mask. And that I'm going to talk quite in detail about because some of it's pretty plain and straightforward, but some of it's kind of screwy. So that's one place it's used, is in the protection of objects. Another place is, okay, now you're in a program and you're going to open a file or an event or a process. You have to declare what kind of access you want to that. You don't just say, open file, and it comes back yay or nay. You have to say, I want to open that file for read access. In general, in a secure system, most of the executables in the system, you'd like to have people have read access to them, but not write access. Viruses like to have write access, and security and viruses don't mix well. So when you do an open call, there's the other place we use the access mask, usually called desired access, parameter called desired access. Getting back to object protection, access control lists are what actually exist on an object to say who gets access or who doesn't get access. And I'll go into those in a little bit. There's more security information related to an object, and it's all housed in something called a security descriptor. And again, this is a data structure that almost universally you can treat as an opaque blob. You'll have one created for you when an object is being created. There are services that do that for you. You get this thing back, and your primary concern is don't lose this. because when somebody comes to open this file, I've got to have it available. So stick it in the file somewhere. Don't lose it. There's a token object. When somebody logs on, this is an executive object. When someone logs on, what we do is collect all the security IDs and a bunch of other information, privileges, and we stick it in an object called the token. That token object is then associated with the user's process. When you kick off the program manager, we stick that token right in. We point to that token right from that process. Any new processes he creates, we copy that token, and that other process has the same context. In general, again, you don't need to worry about what's inside too much. It's just another thing that you're going to have to be able to grab hold of when somebody's accessing a file, and you're going to have to be able to pass this along with a security descriptor and the access mask to the reference monitor and say, hey, Mr. Reference Monitor, this person represented by this token, or I'll actually call it a subject context here in a second, is trying to get this, represented by an access mask, to this, represented by a security descriptor. And then the reference monitor goes off and does its magic and says yay or nay. Okay, the next data structure is the subject context. It turns out a single token isn't quite enough to represent everything in NT. We have something called impersonation. You can have a server that one process calls. And so now this server has its context. It's maybe running as the operating system, or, for example, our SQL server usually runs in an account. So it has its own context. But it also has this context of its client that it wants to be able to utilize. That's a compound context. What happens is during an access, or an object access attempt, somebody has to create this subject context. And in the subject context, we grab a pointer to the processes token. That's the server's context. We grab a pointer to the threads token, and the thread token is the one of your client. So if you're impersonating somebody, your thread has a pointer off to that client's token. And then a little other information about the impersonation, and also some auditing information. So somewhere during that access that object access, we create a subject context. Again, you'd pretty much treat this thing as an opaque blob, pass it along to these access validation and audit calls. Access state is the structure that you're going to be most interested in if you're writing a file system. You've got to do all the stuff to get all these other things, but they're opaque. You don't worry about what's in them. Access state isn't quite that way, especially if you have complicated file system policies. Example of that is in NTFS, there's an access on a directory that says you can delete a child. So if you have that access to a directory, you can delete a file in that directory or a subdirectory in that directory. Well, there's also a delete access on a file. So you can come in and open that file for delete access directly and delete it that way. Well, you could, if somebody asks for delete access to a file, you could in your file system have a policy that says, hey, if they don't get delete access to this file and they've asked for it, we're going to go check the policy on or the ACL on the directory and see if that directory gives them the access. That's a rather complicated policy. It requires multiple calls to the reference monitor. If you take the simpler approach and say, hey, if you want to delete a file, you can either open the file for delete and then delete it, or you can open the directory for delete child and issue that call. But we're not going to automatically go do the other thing for you. That's a simpler policy. It ends up only needing one call to the reference monitor. All this information, if you're going to make multiple calls and things and what auditing going on, is collectively stored in this access state. This is what Robert's going to primarily talk about in his next call, what you have to do to create one of these things, start collecting information in it, and ultimately get rid of the darn thing. I don't really want to go into this, but I just want to stress that a security ID is a variable length thing. It has a revision. It will be changing. it will be changing the meaning of some of these fields in the future. You want to avoid getting too wrapped up in each one of these values if you can. But overall, you shouldn't need to worry too much about them. You get an SID, you pass it to lookup routines maybe, but you shouldn't have too much need to go poking inside. Access mask I'm going to dive into here for a little bit, so let's go talk about that. There's 3 parts to an access mask. It's 32 bits long. 16 of those bits are reserved for the particular object type. So if you look at an access mask for an event object, you'll find out that those 16 bits are different than an access mask for a file or a process. The other 16 bits, though, aren't different. They're the same. No matter what kind of object you're looking at, the other 16 bits have the same meaning. So let's go look at some of those. The first 8 bits are the standard bits. Now, they all start with S, so it gets kind of confusing here. Delete. Every object supports delete access. Universally, throughout NT, you can open an object for delete access. Read control. This, what it's for is to protect the security information on the object. If you open an object for read control, it allows you to read off who the owner of that object is, the group of that object, and the discretionary access control. Write DAC, that's write discretionary access control. That allows you to change the permissions on that file or process or whatever. So if you open a file for write DAC, that person can now change the protection of that file. Write owner, you can change the owner of a file. An owner of an object has certain inherent rights. No matter what the ACL on an object says, the owner can always open that object for write DAC. So if you completely hose it, or the user sitting at some permissions editor completely blows it and says, I want nobody to have any access to this, and says, OK, and then goes, oh, shoot, I wonder if that means me too. That owner can still get back and put on another ACL. He may not be able to read off what's currently on there, so that gets kind of interesting. The permissions editor might say, I can't read the permissions on this, but I noticed that we can change the permissions on this. Do you want me to proceed? And yeah, you can go ahead and proceed. The last one is synchronize. Now, the first 4, every object supports. Every object in NT supports all those access types. Synchronize, most objects support. Well, some objects. And what it's for is if you can wait on an object for completion of something or a signaled state, events, wait for somebody to signal it, semaphore, wait for its count to get to the right value, processes, wait for them to exit. Turns out files support synchronize, and what it is you can wait for asynchronous I/O to complete, and this thing gets signaled. Not every object supports synchronize. Token objects, for example. Doesn't make a lot of sense to wait on a token object. It has no signaled state. I don't think shared memory sections have signaled states. So there's several objects in the system that don't have signaled states, don't support synchronize. And then there's a few reserved bits. Oh, I think I missed one, didn't I? No, I didn't. I'm sorry. OK, now the special access bits. It turns out it's nice to be able to protect a container object. And in a file system, that means a directory. But if you look at a more generic object-oriented world, you might have a container object under which other objects exist. In NT, it turns out our base objects, we do have a generic kind of container object. You can put processes in it, and you can put events in it. If you name an object, you want it to live in one of these containers. And oh, I should have thought to bring it. There's actually, I wonder if we have it. Oh, sorry. There's actually a cute little utility we use around the shop that we can bring up and display, sort of like WinFile. what our namespace is, what our object space is. And you can see, gee, there's a container out here, and it's got all the device objects in it, something you guys might be very interested in. And so you can see all these objects, what their name is, and it just explodes them out and shows you what they are. It turns out one of the most important ways that an object, file, or whatever gets protection is from the directory that it gets created in. You don't want to have to force the user to be constantly saying, gee, I know I just created a Word document. Oh, shoot, I better give it some protection. You want the user to be able to say, there's protection on this directory, and everything below it should get this protection. Well, that was great if all your objects are the same type. File system, that might work. But if you're looking at a generic object-oriented sort of thing where you might have a container and it has both processes, events, tokens, something else in there, you look at these specific access types, and they're all going to be different, right? The specific access types for an event are something like signal event state and read event state. The specific accesses for a processes might be read virtual memory, write virtual memory, weird things like that. So it's hard to put something on a container that gets inherited by all these other objects. So what we did was say, let's invent these generic access types down here. We got, well, here they are down here. All these access types. What you can do now is define for each object type what generic write means. And for a file, you'll find somewhere a constant file write access or something like that. And you'll find out it means the following 4 access types. And file read access means the following 3 access types or something like that. Every object should have such a definition. It's called a generic mapping. And so now what you can do is go to this container object, stick on these generic accesses, and when it gets inherited by these other objects, we actually map it for those other objects. Dave, where is Dave? Somebody, Dave Beaver, show yourself in here and tell me how much time I actually have. These other 2 access types over here are kind of interesting. There's, in the security descriptor for an object, that's the thing that every object has, it has all the security information in it. There's an owner, a group, the discretionary access control that protects the object, and something called the system access control. The owner we talked about has special privileges. Group has no meaning at all. It's there just for organizational purposes and POSIX. The DACL is protection. The system ACL is auditing. And what it allows an administrator to do is go to an individual object and say, I want this object audited as following. And it looks a whole lot like permissions. Instead of saying grant user Sally these accesses, it says audit user Sally failed access or successful access these access types. And you build up an ACL just the same as you would for a discretionary ACL. Now, the thing about auditing is you don't want the owner of an object to be able to go in and change the auditing on an object. That's an administrator's function, not somebody that they want to be able to audit. If I could go in as the owner of an object and change the auditing, that means my administrator could have no mechanism to audit me. I could always turn it off. So what we did was invent another access type that controls access to that, and we completely ignore that if you stick it in a discretionary access control list. If you specify it in an open attempt, you need a privilege, a user right. And so if we see that in an open attempt, we go and check your token to see if you have that user right. The last one is maximum allowed access, and this is kind of a cool thing. If you're, say, Microsoft Word, and somebody just clicked open a document, there's a couple possibilities. One is you don't have any access to that document. You're going to have to come back and say, sorry, I can't open that. Another one is you only have read access to that file. And the last one is you have both read and write access to the file. Well, the easiest way to go and open this file is say, I want maximum allowed or read, or those two access types together. What that tells us is they want to open this thing for whatever access they can get. But because they or it in read, they have to be given that or we'll fail the open attempt. And so what we do when we see maximum allowed in an access, we go and walk the entire discretionary access control list, check each ACE, which is, an ACL is made up of individual entries called ACEs. We check each one of those and just start ORing in all the accesses you've been given. And when we reach the end, you've either been given something or you haven't. If you haven't, we reject the open altogether. You can't open an object for no access. If you have no access to an object, we don't want you tying up a ref count to it, preventing it from going away. If we get to the end and you've been given something, then we check it against your original desired access and say, okay, he said maximum allowed. Were there any others he has to have? And if so, are they in here? And if that's the case, we go ahead and give access. So that's kind of a cool feature. Dave, what time do you need to start the Q&A before lunch?
If you can wrap it up by like 5 till noon, that's fine. We can go there
Okay.
Take the time to take.
No, I think, well, I don't know how much I'll bamboozle people, but okay.
Just do your job.
All right. Okay. Get this thing back. An access control list, I'm not going to go into this a lot. It's a variable length thing. It's got a revision. It will most likely change in the future. You shouldn't have to deal around with it too much. There are API, Win32 API, and also executive level API, base API for playing with these things, so you can if you want to. They're pretty well documented in the standard documentation in help files and stuff. And a lot of this stuff I'm also in the process of right now, putting more information in the MSDN CD. So I would imagine most of you get that. There will be a lot more information. We have some architecture level information on ACLs, security IDs, access masks that go into all what I'm talking about in quite detail. So if you get that, we'll be adding that real shortly here. Yeah?
Well, privileges. I find the privilege documentation pretty vague.
The privilege documentation is pretty vague. There will be some of that in there as well. I'll check and make sure that we actually put in more.
What privilege do you need to assign privileges?
What privilege do you need to assign privileges? Turns out assigning privileges is controlled by access control lists, and you need to be an administrator. How is the administrator identified?
Take a control block and you look at a whole bunch of CLA or actually cases. How would you be able to identify that administrator or not?
I didn't hear all of that, but I think the gist of it is, how can I tell if someone's an administrator? There's one local group in the system, one special group called administrators, and it has a very well-known ID. And if you have that ID in your token, you are an administrator. So if you've been made a member of that group, you are an administrator. Is there a difference between an administrator and someone who's a member of the administrators group? No, that's the definition of it. If you are a member of that group, you are an administrator. Now, there's also a user account called administrator, and that account is special. We don't let you pull that account out of the administrators group. You can try all you want, we'll reject it. We also don't let you disable that account. You can rename it if you want, not how we encourage it. Because that makes it a little harder for people to walk up and start trying to guess your administrator account password, especially if they don't know the name of it. Don't forget the name of it. Security descriptor. We'll get a cooler picture here in a second, but these are all the things in it. Again, it's got a revision, some control information. There's two flavors of security descriptor. One is typically used when you create an object. You can specify some or all of this information. Very few people do, except those of us that wrote the operating system. But if you are writing an application and you want to, for example, force a user to tell you what permission to put on this new merger document that you've just written up between two huge companies, this is how you would specify. You put an ACL in a security descriptor. In the control flags, you indicate that there is a discretionary ACL present and pass it along with the create call. So we'll get to, here's a better view of what a security descriptor looks like. It's got a couple of SIDs in there describing the owner in the group, and then the discretionary ACL, and discretionary ACLs either grant or deny access to the entries in it. And then the system ACL tells what kind of auditing to perform. So in this case, the discretionary ACL would grant the account called payroll in accounting read and write access, the account called Megan B read, write, and delete access, and internal read. And it would audit everybody that wrote to this file or whatever it is. Oh, it says file on top. It's file. Token, I like this little picture, so I stuck it in. Tokens, again, they have a user ID, all the groups you belong to, and then all the user rights or privileges that you picked up along the way. User rights, I call them privileges a lot because at the UI you see user rights. User rights are really two things. Privileges, which is an internal thing. You'll see some API that have the term privileges in them. And system accesses. If you click on the user rights menu in the user manager, it'll drop down all the privileges, and then you'll also see log on system interactively, log on system as a service, log on system via the network. Those aren't privileges. Those are just system access types, and we clumped those things all together and called them user rights. But if you're coding, you're probably going to have to be aware that there are two separate things called user rights. One of them are privileges, and they get stuck in your token. System access rights, we use it to determine whether or not you can log on, but once we make that determination, we don't need to keep it in your token, so we don't. Okay, the subject context we talked about a little bit. Along the way, during an access request, one of these gets created, and Robert will talk more about where, in respect to file systems, it gets created. But I believe, in general file systems, it's done for you. By the time it gets into a file system, you've got one of these. All right? It points off to a token for your process. It always has one of those. You can't have a process in the system that doesn't have a token. It has something called an audit ID. So if we're generating audits for this access attempt, they all get this ID. So if you have a complicated policy check, like the file in the directory example I talked about earlier, it might actually generate several audits. You're calling the reference monitor saying, this user wants this access. We might end up having to create an audit for that. If we create 2 or 3 audits, it would be nice to know that they're all tied to the same access attempt. So that's what this audit ID is for. Client token, if you're impersonating somebody, the subject context will have one of those. The impersonation level, it turns out when a client calls you, they can specify something called the impersonation level. That gives you certain use of their context. I can call a server, and if that server is, say you've written a Star Wars game server, and it allows up to 20 people to connect up and be Klingons and whatever the heck, and they're all playing this game, and this is the thing that coordinates them, decides who's killing who, right? You really don't want to be passing the ability for that thing to be opening files. You got it off of some network somewhere. You have no idea who wrote it or what the code looks like. You don't want to be calling that thing and saying, here, you can be me for a while, because it might be Trojan. It might be sticking things in files or in boot partitions or whatever. So you can call it saying, that guy doesn't even get to know who I am, anonymous impersonation level. Or you can call something like, a SQL Server. The SQL Server doesn't really have any need to go out and access any files on your behalf. It opened one file as itself, and all its objects are tables and rows and joins and whatever the heck that are its objects. It doesn't need to access other objects. It just needs to decide if you have access to its objects. You can pass that kind of server an identification level impersonation. He can look in your token and see who you are. He can pass it to an access validation routine and say, here's a security descriptor, here's a token, and here's an access mask. Tell me whether or not this all works. But he can't turn around and call open file with identification level. The last level is impersonate level. And that's the one that if you call a server with that, they can turn around and go out and open other objects. So they could open a file. And oh, what's a good example of one of those? If you had a really fast processor somewhere and you stuck a C compiler server on it, you know, you could compile. It was multi-processed, and you had a 16 processor machine out there, and it took about 2 milliseconds to compile any file you had. He would be opening the source, listing, you know, everything file, object file. So there's an example of that. Access state, I'm going to leave for Robert to talk about. Security operations. Let me glance at what I've got to go over here. Some of this is going to be a little review. Log on, you go through, I should have that picture here. The logon process collects all your identification and authentication information. That's username and password, or maybe you stuck in a smart card and it collected off certificates and needs to check those certificates or something. Passes those over to LSA, and we'll get to that here. Passes those over to LSA. LSA hands it off to whatever authentication package that you want to validate that information. That authentication package turns around and says yay or nay. Either it's a legitimate logon or it's not. If it's a legitimate logon, it hands back the initial set of IDs. LSA at that point takes that set of IDs, compares it to its local policy, which includes what privileges do you have, what local groups are you in, and may add more stuff to your list of IDs. Eventually, LSA gets to the point where it takes all that stuff and creates a token and returns it to the logon process. So that's logon in a nutshell. Oh, this will take a while, I'm sure. Going back to that. There is documentation that I'm adding to the MSDN right now that talks about each one of these interfaces. The interface provided from LSA to a logon process, the interface within LSA if you want to write an authentication package. So any of you that might be doing like networks or want to do your own UI or logon, that information is being added to the MSDN. Hopefully, by the time we ship the PowerPC release, we'll have that. I jumped the gun, talked about impersonation before we got here. These are the levels. There's also two other bits of information having to do with impersonation. One is tracking. When you call a server, you get to specify, do I want this server to take a snapshot of who and what I am right now, or do I want the server to come back and use my context whenever he needs to? So if I'm constantly turning on and off privileges, things like that, you might want dynamic tracking. If you're impersonating somebody and call over, you probably want static or something like that. It turns out there's performance implications here. If you do dynamic tracking, we're very fast and efficient. We just point to the other guy's token. If you do static tracking, we have to copy the token at the time the call is made. And in general, if you're writing a file system, you don't see any of this. You don't worry about it. Effective only means when it gets over there, if there are privileges in the token, the server can't turn them on or off. They're either on or off as they were when the call was made. Each communication mechanism in the system has to provide impersonation services. If you look at NT, we have LPC, we have named pipes, DDE, RPC, you can stick on top of any of those. They all have impersonation services. For RPC, I should point up here, not down there, huh? RPC, it's really simple. You've received a call, you say RPC impersonate client, or impersonate, I guess. And it goes to whatever session layer it's using and makes the right call. But if you're tailored to name pipes or something specifically, name pipes has to provide them. If you are writing a communications mechanism, you will need to provide this mechanism. Here's a very faded view of what impersonation looks like. This represents a process. The token up in the right corner is who that process is logged on as. It has 3 threads running in it. One of those threads is currently impersonating someone. Now I'm going to, at this point, go to something that we use inside. And I think this is in the resource kit. Called PView, but there's another PView that shipped with the system, so there's 2 of them. It gets kind of confusing. Process Explode or PView. This is kind of cool. You can look at various processes in the system this way. And I can't see very well, but okay, we're going to pick WinLog on here. And here's a whole bunch of information about him. Among other things, you come down here and say, what's the ACL protecting that process? This is a discretionary ACL sitting on that process. It says administrators have some special access, and we can go look and see what that is. Administrators can read the ACL and owner information. They can wait on the process to exit, and they can read its virtual memory or query other information about it. But the other thing you can do, come down here and say, who is this guy, is basically what it comes down to. Who is this process? And this is the contents of that process's token. Its ID is local system. It's part of the operating system, which has its own context. It looks like a real logged on user. All these system processes, of which we saw quite a list there, I'll go back to in a minute, each one of those has a token. So the operating system didn't really log on. There's a cute little routine that we use during boot that fabricates an initial token, and all the rest of the operating system inherits that token. It has 2 groups that it is a member of, the operating system is. One is it can look like an administrator, and the other is it's part of the group I call world, but program management changed to everyone. It's something used to represent everybody. And these are all the privileges. And you can see there's a whole bunch turned on in WinLogon. I don't know how many, but... And you can sit here at this UI and do all sorts of neat things. I just turned on something, I'm not sure what. WinLogon now has another privilege turned on. It's okay to turn them on, you don't want to go in and turn them off. Like I say, there's a whole bunch of processes in this system. And all of them that are the systems have that context. We get down here toward the bottom, and this is one of mine, I think. Who is this? Clock. I guess we have clock running. This is what I looked at like logged on. Dave Beaver, we logged on as DeBeaver. He is an administrator on this machine. And in fact, there's an interesting point. If you're a member of that administrators group, we do something funny during logon. Normally, in token, there's one ID called your user ID. And when you create an object, that user ID gets assigned as the owner of that object. If you're a member of the administrators group, though, we decided, administrators tend to do things like install software, move things around. And if you have 2 or 3 administrators on a server, one might install something and someone else might come in and have to do something else to it. don't want the first one being the owner and putting on one permission that prevents another one from coming in and doing something. So if you're an administrator, we set up that local group as your default owner. So when you come over to this thing and look at what your default owner is, you've got two possibilities. One is your user ID, and the other is this local group. So that has puzzled people in the past. I created an object, I created a file, and it made administrators the owner, and I'm Joe user. How come I'm not the owner? This is why. Some of these other IDs, during the logon process, we were told, the local security authority was told what kind of a logon it is. Is it coming from the network? Is it coming from the service controller? Or is it coming from an interactive mechanism? We stick in a group indicating what kind of logon it is. So if you want to restrict access to only people that are logged on interactively, you can do that. And a couple of other funny groups you can read about in the documentation if you want. They're kind of funny. So normally you won't see too much of this, but this is a handy little tool. And I think that's in the resource kit. Let's see. Well, I'll tell you what here. I have a little bit more to go. Well, let me just skim through it real quick. We've talked about access validation to a good extent. That we've got this kernel mode thing called the reference monitor. Robert's going to talk in pretty good detail about how to interact with it from a file system. A good chunk of what he's going to talk about also applies if you're writing a user mode server. You don't have to deal with this access state, but all the services that you use to do an access check or an audit or a privilege test, there are corresponding user mode calls to be made, Win32 calls. So if you're writing a user mode subsystem of some kind, same sort of things apply. When a new object is created, I alluded to a second ago, you get new things on it. You get an owner of that object. I talked about some protection being assigned. One way is to inherit it. There are other ways. Here are the rules for what you get. For the owner, the person that's creating the object has the opportunity to pass one in and say, this is what I want the owner to be. If that's the case, we'll assign that as owner. Now, you can't assign just anybody as owner. Eventually, we'll be doing things like disk quotas. And disk quotas are typically based on owners of objects or groups. And so it's very cool. You know, you're a student, right? You've been given 200K of disk quota. You know, it's precious. You don't want to use it up. So you start assigning other people as owners of your files and chewing up their disk quota. Well, we go back to your token and check to see, you saw where I dropped down the default owners? That didn't include all your groups, and it certainly didn't include everything else in the world. We restrict who you can assign as owner. So you can pass in whatever you want, and if it doesn't match what's in your token, one of the things in your token, we're going to reject it. Otherwise, we're going to pull the default token out of your token. I mean, the default owner out of your token and go with that. Group. You can pass anything you want. It has no security meaning whatsoever. So group, we don't care. It's there for POSIX. They're just. You don't enforce authentication. The question is, you don't enforce group authentication. The group of an object has no security meaning. If you use a group in a discretionary ACL and say group, Department X should be given read and write access. Yeah, that we absolutely, that means a lot. But what you stick as a group of an object, we don't have, for example, in Unix, you'll see their access control lists are very short and sweet, right? System, group, other. And you check the group of the object, check to see if the user's in that, and then you give them that access. We don't have anything like that. You explicitly stick in here what group. You don't say relative to the group of the object. So it has no security semantics at all for us. Discretionary ACL, again, you can pass one in explicitly during the create and say, this is exactly what I want put on. If you do that, we'll put that on. And the creator of an object can put on whatever they want. Otherwise, and typically, this is what happens. We go to the container you're putting it in, and we try and inherit information. And there's a whole architecture for how to set up inheritance. There's also a whole permissions editor that does it for you if you're writing something and want to just ignore all that. Otherwise, if there is no inheritable protection on a container, we'll go back and say, did he provide a server default? And that's something that, say you're that C server, C compiler server, and somebody called you and said, compile this file and put it here, and by the way, here's an ACL to put on the object file. We provide a mechanism for you to pass that through. That's the initial one. Or if they don't pass you one, the server, you can provide a server default, and it falls in a different place in the assignment. So then we'll go back to the passed in descriptor and say, did the server provide a default? Otherwise, we say, this object has no protection, and leave it wide open. System ACL is real similar. There is no server default, so you can explicitly pass one in, or we'll inherit one from the parent, or, I'm sorry, there is a server default. Otherwise, it has no system ACL. If you pass one in, you have to have a privilege to do so. There's a security privilege that anytime you're playing around with a system ACL, you're playing around with auditing, you have to have that privilege. Is there such a thing as a domain default? No, there isn't. You can set up domain policy for what kinds of auditing to do, but there's nothing that says which specific files should be audited. You'd have to go to each volume and say, I want this auditing on this entire volume. Except for very, very security conscious customers, it's rare to audit accesses to all your files. Usually you have some subsets of files. And so it would be hard to set up a domain policy that says, I want this, the following 3,000 files audited, but any other, of the 22,000 files we have, we don't care about. So it'd be kind of tricky. And there. Dave, you want me to take questions for a few seconds before we go into general questions, or how do you want to do this?
I'm headed your way.
You're headed my way.
Rather than hold up the nice hot lunch that we have coverage for memory management, et cetera, at the end of the day. So we'll just take questions specific to Jim's talk, and we'll continue with the Q&A at the end of the day rather than doing one before lunch. So this way we get lunch and et cetera, et cetera.
And I'll be in at lunch too, so I can be pinged further.
Go ahead and take some Jim-specific questions, and then we'll go to lunch.
Okay, is there a microphone? Yeah. Do you want him to use the microphone?
Yeah.
Go ahead and use the microphone.
We should make it about 5 minutes or so with questions and then head for lunch.
You interrupt me.
Okay.
Yes, on the impersonation, currently you can only impersonate a token that's connected with a communications link of some sort, or at least at the Win32 level. If we have an application that does automation and wants to run a batch job, say, in the user's context, say restore job, just for the heck of it, in the user's context, when the user's not available, how would you do that?
There's two ways I could think of to do it. One, they probably called you to submit the job.
But they might have done that, earlier in the day. This is like they've gone home. They want to run this thing at night after they've gone home.
That's what I was going to get.
And you're going to start this job later, effectively.
Yeah, there's kind of two flavors. You either have a batch queue that you want to be able to start these jobs following a reboot, or not following a reboot.
Right.
If you want to be able to start them following a reboot, then you have to collect username, password information that you can use later. And your batch queue would register with LSA as being one of the logon processes, and it would call, there's actually a system access type. I only listed 3, network, interactive, and service. We actually invented one called batch. And so you'd register and say, hi, I'm batch, a logon process, and then pass in that information either to our authentication package, the interface to that's documented, or you could provide your own authentication package to do the logon.
Okay.
So somehow during the submission of that job, you want to collect their username and password. And we don't save that away. As a security measure, we don't save that away in NT. You enter it, we throw it away. Or we don't actually throw it away, but we keep it in a way that isn't very useful.
Okay.
We can re-authenticate against it, but we can't use it to authenticate further. Does that answer that?
Sort of. How about if I want to do it within a thread, a particular process, there's no way to do the impersonation still within the thread, even if I've saved that information away? I mean, what you're talking about would create a new process that would do that.
Well, when you log on, you're going to get a token back.
Right,
Now,
right.
there's token duplication services that you can, there's two flavors of tokens. One's a primary token, and you can assign those to processes. Another is an impersonation token, and you can assign those to threads. Given one of those kinds, you can duplicate it and make another one.
Okay.
So if you log this guy on and we give you a primary token, you can duplicate it, get an impersonation token, and create a thread and do his job directly if you want.
Okay, got it.
Okay?
Hi. I'm trying to clarify in my mind the basic workings of the impersonation mechanism. Given that object handles are allocated on a per-thread basis and that the access...
Object
true?
handles aren't allocated on a per-thread basis. They're process. There's a process handle table.
Okay, process.
Okay.
Right. So I thought someone said threads yesterday. And given that access is all checked out at the point when you create the handle to get at an object, in the context of impersonation where process A is doing something on behalf of process B,
Right?
what handle does process A use?
It's up to process A. Process A is now a server of some kind, right? Like, for example, we have the security account manager, which controls all our accounts, is a server. It's got lots of handles open. You have to distinguish between when a client calls in, you have their context available, and you might be impersonating them, but they aren't controlling you. It's still your code. When they call and say, create user, for example, it's going to enter you at a certain place, and you've got this create user code. Okay? That create user code isn't going to use any handles that you didn't intend that user to get to. Right? Like you have a handle off to the security database directly where, you know, your internal data structure is representing all the accounts. That user, even though he called you and you're impersonating him, that user has no way of saying, hey, this is cool. I want to use that handle to that file and tweak it a little bit. So you have to build your server so that it accidentally doesn't give that user access to things that you didn't intend him to get access to, which usually means you impersonate, do an access check, and then stop impersonating, right? And now go and do your stuff.
Right, but you'll do the access check. Thinking possibly in the context of something like an environment subsystem where you're trying to, for example, creating a file or accessing a file, doing I/O operations with...
Well, there what you usually end up doing is having a context block representing each client. And so now a client calls into you, you quickly look up their context block and say, great, here's their context block. And here's the set of handles I've opened on their behalf. Okay? And you won't reference any other handles. If two clients have called in and opened files through that server or something, you'll come in, grab their context block and say, here's the 7 handles this client has open. Here's the 4 handles that guy has open. Okay?
Right, so the answer is then that the server or the environment subsystem is using its own handles, which have been specifically created in the context which apply the security context which is relevant to the access.
Precisely, yeah.
Good, excellent, thank you.
Okay.
Yeah, you said the APIs for interfacing with the LSA is currently documented. And could you tell me specifically exactly where that's currently documented?
Well, I said it's being added to the MSDN. Okay.
Is that going to be soon? Or?
Real soon. I was working on it this morning. I'll be working on it this afternoon.
Okay, and
it's real high priority.
That'll have facilities.
You can also call our MCS, the Microsoft Consulting Services. They're equipped to help with that until I get it out.
Okay, and that'll have facilities to create primary tokens and assign them to processes and threads?
can log someone on and obtain a primary token. There are no services to create a primary
Right.
token.
You can log somebody on if you have their user ID and password.
Right.
Okay.
Yes, you can do all that.
That sounds good.
Okay. Any others? Everybody's hungry? All right. You want to say anything?
Let's have lunch.
Let's have lunch. Go eat.
Let's have lunch.